start here. Before we start though, was there anyone who wasn't able to upload their work on Moodle and wants me to check it now? So I can give you that completion mark. Do you have the practice set? Did you got these last day though, right? Yeah, okay. So there were some handouts last day just for extra practice for mortgages. So if you didn't get one, come grab them. I've got lots. But also, does anyone need a practice test? Copy of the practice test? Everyone's good? All right. Cool. Oh, can you show it to me now? Yeah. Or can you just email it to me, maybe? Yeah. Awesome. Okay. Oh, I did start it already. Okay. So, review day. All right. Let's do this. So, practice test 3. Hopefully you were able to upload your work on Moodle, so I can just give you a completion mark. Right, nice and easy. Doesn't have to be right or anything. But today, I'll just post the solutions to the short answers, and then we'll just go through the long answer ones together, right? Because those are the important ones. So I'll just steal them. Yeah. Sure. Okay. And these are your long answers?
No, I only need two questions.
Okay. Yeah.
I'm on B.
Oh, here.
I'm also having my midterm.
Okay. All right. So, like I said, we'll just go through the long answers together. If you have any questions, then I did come across a typo in one of the questions when I was going through it, so I'll talk about that. But it says end of the month bi-weekly payments. Weird. Anyways. All right, but let's start with this one. This one's fine. So Jim purchases a mortgage with a $60,000 down payment. He pays end of the month payments of $2,000 for 25 years. If the interest rate is 4% compounded quarterly, what was the original value of his mortgage? Include a timeline in your answer and do all calculations without using the calculator, essentially. All right, so we have to do this one by hand. Notice that that's the only one that it says you have to do it by hand for. The other ones, you're welcome to use your calculator. It's going to be a lot easier, right? Oh, what I will say about the short answers is I'll give you these here. I'll make a little bit of room here. So each short answer question is going to be worth 2 marks, right? And I'll give you boxes just like these ones. If you filled in the boxes correctly, that's worth 1.5 marks out of 2. Okay. What that means is if you don't have time to go through and actually find the values on your calculator, right? Because this test is a little bit long, so you do have to keep your pace up, right? And so if you go through and at least fill in the values, what they would be, you can still get 1.5 out of 2. Okay? So, each short answer is worth 2 marks. Okay. and filling in the correct calculator values is worth 1.5 marks. Right. So to save time, right, if you want to start with the short answers, fine, but just fill in the tables. Don't actually do the calculator work until you know that you have time to go back at the end and do it. Right, take that 1.5 and then, yeah, go in and get that half mark later, but only if you have time. Right. So. Mm-hmm. All right. So like I said, this is the only, so the first long answer is the only one that you're going to have to do by hand. The rest, you're welcome to use your calculator. And I encourage you to use your calculator for especially the second to last one. And you have to use it for the last one. Right? 5 and 6, you kind of have to use your calculator unless you want to get bogged down in calculations. Okay, so let's map this out, right? For all of these, we have to include a timeline, right? And so we'll start out and we'll say, okay, well, make a nice long line. And I know I'm starting today. So he purchased the mortgage with a $60,000 down payment. He pays end of the month payments for 25 years. So at the end here, I'm at 25 years. I'm just going to write that a little bit above, right? Because I know I'm making monthly payments, just making room for how many months I have at the end. And so at this point, we're pretty comfortable with calculating the number of payments. And so 25 times 12 is 300 months. So for 300 months, he's going to be making payments. So the second to last payment is $299 months. 1 month, 2 months, right? I want to see 2 at the end, 3 ticks at the beginning, and then dot, dot, dot. Right? So a total of 5 ticks. He's going to make end of the month payments, which means our first payment is at the 1 month mark. Right, remember if the payments were at the beginning, which they very well could be, right? Easy switcheroo, right? Then you would have to put your first payment today, right? But because it's at the end of the month, we start our payments at the 1 month. So we've got a payment here. Oh, 2,000. We already know what it is. 2,000, 2,000. 2,000 and 2,000. If the interest is 4% compounded quarterly, what was the original value of his mortgage? I realized when I was going through and doing this one, just quickly, the value of the mortgage, right, is technically just the value of the loan, right? But I'm gonna, if you went a little bit further and found the value of the home, then that's fine. I'm going to say, okay, so we had a $60,000 down payment. And then these $2,000 payments for 300 months is going to funnel back to some present value. If I add those up, I'll have the total value of the home. If you just interpreted it as finding the present value, then that's fine. I'm flexible. On the test, I'll make sure that it's obvious. And yeah, I'm gonna ask you for, what was the total value of the home? Right. So that's why I'm showing it here. All right, so let's jot down some information that we have, right? So we've got our compoundings per year, quarterly. We had payments per year of monthly, so 12. And if they're at the beginning or the end, they're at the end of each month. And also the rate was 4%, so 0.04. Remember, the compoundings per year is always F1 and the payments per year are always F2. And if they're not the same, which most likely they won't be, right, you have to find I2. Right? So which means you first have to find I1 and then you have to find I2. So I1 is R1 over F1, which is 0.04 over 4, which is a nice 0.01. Then before we can even do any calculations, we also have to find I2. I2 is 1 plus I1 to the power of F1 over F2 minus 1, which is 1 plus 0.01 to the power of F1, which was 4, divided by 12 minus 1. 1.01 to the power of 4 divided by 12, and then minus 1. I get 0.003322284, which I'm going to store in 1. Okay. So the goal here was to find the present value of these payments. And so we have to use the present value formula on your formula sheet. It's just an ordinary annuity, right? Because the payments are at the end of the payment period. Otherwise, you'd have an annuity due. So the present value is the PMT times 1 minus 1 plus I to the negative n over I. Our payments are 2,000 times 1 minus 1 plus, and if you want to just, instead of writing in I2, you are allowed to write recall 1 as long as you've told me where you've stored it, right? So if you wanted to write here, I'm going to write in the number, but if you wanted to write recall 1, that's okay, right? That's allowed. I'll write the number just mostly for people who aren't here. They might look back and be like, what is going on here? So 1 plus 0.003322284. 3 2s, yeah. To the negative n. N was what? 300? 300 payments? 300 over 0.003322284. I'm going to find everything in the big brackets just to save a little bit of writing here. Plus 1 to the power of 300 negative equals 1 minus that divided by recall 1. I get 2,000 times 819.375424. Times that by 2,000. I do not get the same value I got earlier. And I know that value is right. So I must have screwed up here. Hang on. 1 plus recall I have the wrong recall one. That's why. All right. 0.01 plus 1 to the power of 4 divided by 12 minus 1. Store in 1. There we go. Plus 1 to the power of 300 negative. Oops. 1 minus that. Divide by recall 1. I still get 189. Oh, but that is it. Not sure why. Okay, 189.7155314. That times 2000 is 379,431.0628. So in money, we've got 379,431.06. Let's take it that one step further and say, okay, well then the total value of the home is 60,000 plus 379,431.06, which is 439,431.06 dollars. Okay. Good. Any questions about that one? That was pretty straightforward, but it's because you have to do it all by hand, right? You can't use your calculator, and so, yeah, hard enough. Yeah. Then let's move on to question 3. I guess the second long answer. Okay. So Ted purchases a plot of land for $200,000 with a 15% down payment. He then makes end of the year payments for the next 18 years to pay off the property. Assuming that interest is 3% compounded weekly, what are Ted's payments? Okay. So let's make our timeline. Of course, we have to include a timeline. So today, and then we're making yearly payments. So 1 year, 2 years, for 18 years. Right, that's nice because we don't have to calculate the number of payments because it is just yearly. 17 years. ... So he's going to make end of the year payments. So he's going to make a payment here, and a payment, and then the last payment at 18 years. Over here today, let's talk about what these payments are actually paying off. These payments are paying off 200,000 minus 15% of 200,000. Right? So minus 200,000 times 0.15, which is 30,000. So he's actually just paying off getting a loan for 170,000. So these payments are paying off this present value of 170,000. Okay. We're told that the rate is 0.03 and compoundings per year is weekly, so 52. The payments per year is 1. And beginning or end, we're at the end. Compoundings per year is your F1, payments per year is your F2. They're not the same, so we're gonna have to find I2. And what I'm gonna do for this one and question 4 is I'm gonna find them by hand because your calculator work should match up. So I'll show you how to do it by hand because it's more work, but then you can check it. Okay. So we first have to find I1, which is R1 over F1, 0.03 over 52. .03 divided by 52 is 0.01230057693. I'll temporarily just store this in 1. Then I can calculate I2, which is 1 plus I1 to the power of F1 over F2 minus 1. One plus 0.000576923 to the power of 52 divided by 1 minus 1 plus 1, oops, to the power of 52 over 1 minus 1, 0.030445562. Now I'll store that in 1 instead. All right. So the 170,000, right? That's a present value. So we know the present value, and that's what we have to use to find the payment amount, right? On your formula sheet, you've got either the present value or the future value formulas to choose from to find the payment amount. And the payments are at the end of the payment period, and so you just have an ordinary annuity, right? And so we're going to use that same formula that we were just using, where the PV is the payment amount, which we're now solving for, times 1 minus 1 plus I to the negative n over I. So the present value is 170,000. We're trying to solve for the payment amount, 1 minus 1 plus, and then again, you're allowed to put recall 1 if you want, but I'll just do the numbers, 0.030445562 to the negative, just 18 years, yearly payments, over 0.030445562. So plus 1 to the power of negative 18, 1 minus that, divided by recall 1. I have 170,000 is the payment amount times 13.7018395.7. So then my PMT is 170,000 divided by 13.7018395.7. 170,000 divided by the previous answer, I get 12,407 0.09316. So in money, that's 12,407.09. So the yearly payments for the next 18 years would be $12,407.09. Any questions about that one? Nope. Okay. Moving along then. Here's the one with the typo. I'm sure you caught it though. So it says you currently have $30,000 in your RSP. You will let it collect interest at a rate of 4% compounded weekly. You will let it grow until it can sustain month-end payments of $500 bi-weekly forever. Oopsies. So there's month-end, but also bi-weekly. What I'm going to do is I'm just going to scratch out the bi-weekly and use the month-end. If you use bi-weekly, that's fine, but it will change the answer, right? Because you'll need different amounts of money for bi-weekly, but I'll make sure there's not typos like that on the test. How about? And if there are, you have to ask me about them. Okay, so you've got 30,000 sitting there. You're gonna let it grow until it's the size that you need in order to get $500 payments at the end of each month forever, right? Whenever we're getting payments forever, or making payments forever, but getting payments forever, right? You've got a perpetuity, right? And so, all right. Notice another thing here, that it's going to be 4% compounded weekly, and then for your perpetuity, it's going to be 5% compounded weekly. So they're not the same. How long will you need to wait until you start receiving the payments? And so here, if we start today, and I've got 30,000 in the bank, at some point, some unknown time point, I'm going to start receiving month-end payments. So 1 month, 2 months, 3 months. And then here, what I'm going to do is I'm just going to make this a little arrow to show that it's going to keep going on forever. And so I've got this perpetuity, and it's going to keep going on forever. Oh, I guess I should put my payment amount there first. $500 at the end of each month. So 500, 500, 500, just keeps going and going. These all funnel back to a present value of a perpetuity. If we needed these payments to start immediately, you would have a perpetuity due, bless you. And so we need to figure out, okay, what amount do we need? Oh, here, well, there, here. So what amount do we need this 30,000 to grow to? That's going to be the present value of the perpetuity, right? And then we can figure out, okay, well, how long is that going to take at 4% compounded weekly? So what we've got is we've got this section, this perpetuity section has a rate of 5% compounded weekly. And then this next section has a rate of 4% also compounded weekly. So we've got different rates that we have to deal with. Okay. On this side, we've got monthly payments, right? So we've got payments per year is 12. So in order to work with that, right, we have to find I2 just because 12 is not equal to 52. So we've got, here's our F1, here's our F2. From the 30,000 just sitting there growing, there are no regular payments, right? So there's no payment frequency. It's just 4% compounded weekly. So we have to deal with the perpetuity first, right? So find this one first, and then this is going to be equal to the future value of that one. So once you have that perpetuity, the present value of the perpetuity, you know that that's the future value of just your compound interest section. And then you can find n. N is this. I'll put a little subscript 2 on the future value, even though it'll be the same value as the present value of the perpetuity. So step 1, find the present value of the perpetuity. Need I2 first. Well, first we need I1, and then we can find I2. So I1 is R1 over F1, which is 0.05 over 52 lots of zeros. 1, 2, 3. 1, 2, 3 zeros. 9, 6, 1, 5, 3, 8. Store this in 1 temporarily. And then I2 is going to be 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.1, 2, 3, 9 zeros, then 9, 6, 1, 5, 3, 8 to the power of 52 over 12, then minus 1. I get 0.004173349, which I'll store in 1. All right. The calculation for the perpetuity is really nice, right? Once you have I2, then you can find the present value of the perpetuity is just whatever you need your payment to be over I. In this case, we need payments of $500, and I is 0.004173349. So we need 119,807.8565. So in terms of money, we need 119,807.86 pennies in the bank, right? If we're able to deposit that, then we'll be able to take off interest of $500 every month forever, right? Each compounding. Okay. So now we know that, okay, our 30,000 has to grow to 119,000-ish. Right? How long is that going to take? Let future value 2 equal 119,807.86. How long will it take 30,000 to grow to 119,807.86. Here, remember we've got that different interest rate, right? So we have to calculate I again. So I is R over F, which is 0.04 over 52. 0.123 769231. I'm done with the other one, so I'll just store this in one. One's a popular storage locker. Although someone told me last term that he prefers to use 0 as his go-to storage locker. And I guess he's got a point. It's kind of out of the way, but I don't know. I'm stuck on 1. Anyways. Okay. That's neither here nor there. Now, because this is just compound interest rate, we've deposited some money and it just sits there. There's no regular payments happening. Now we're back on the front page, right? I just call this section compound interest, even though I know we've got compound interest everywhere on here, right? But it's different because it's annuities, right? So here we're just back in a compound interest situation where we've got the formula for N. N is the log of the future value over the present value over the log of 1 plus I. So then we've got the log of the future value, which was the 119,807.86 divided by 30,000 over the log of 1 plus 0.000769231. 119,807.86 divided by 30,000. And then I take the log of it, just because I know I have to, is going to be 1.384691911. I'm going to store this in 2. Why not? And then I've got 1 plus recall 1. Take the log of that is 0.0, 3 zeros again. 1, 2, 3. 768935. Just in case, I'm going to store that in 3. And then now I'm going to do recall 2 divided by recall 3. 1,800.791742. Here's an important thing, right? And we dealt with this on test 2 as well, right? We have to round up our N to a whole number. And so we would need to wait 1,801 for compound interest, right? N is just the number of compoundings. Right? So 1,801 compoundings. So N is time times the frequency. So 1801 is time, which we're trying to find. And the compounding frequency was 52. So time is 1801 over 52. Oops. 34.63461,538 years. That's a while. And if you think about, okay, well, how long is it going to take for me to get, because we already had 30,000 in the bank, and then we're just letting it grow for 30, almost 35 years. And then we can get, what is it, monthly payments of $500 forever. But, well, for as long as you live, I guess. No, you could pass it on to your kids. Any questions about that one? Good. All right. So 5's a bit of a doozy, right? Tricky. What I'm going to do for 5, and like I said, I encourage you to do the same, is I'm only going to use my calculator, right, to do all this work. I really don't think that you should be doing it by hand. You can, absolutely you can, but it's going to take a while. Okay. So, oh, wrong one. Okay. So, here we've got this doozy. So Oscar had 44 years on Sesame Street where he put away money at the beginning of every month. And his RRSP earned 7% compounded monthly. So that's for 44 years. When he officially retires after 50 years, right? So between 44 years from now and then 50 years from now, the money is just going to sit there. Right? So we've got this kind of gap. And we're going to assume that it's 7% compounded monthly for that time as well. So after 50 years, when Oscar will receive payments from an annuity, earning 5% interest quarterly. So here, I'll do a different color. 5% interest quarterly at the end of every bi-weekly period for the next 15 years. So we've got different payment frequencies, we've got different compounding frequencies, we've got different rates to deal with, right? Different lengths of time. And so what we eventually want to find is how much were Oscar's monthly RRSP payments. So let's map this out in a timeline just so we can see what's going on. So let's say he starts today, and I'll move this over just a little bit. What I'm doing is I'm going to put the 44 year marks. So the year marks, I'm going to put it just up a little bit, right? Because I want to put my number of payments down close to the tick so I can have them easily there. And then here at 50 years. And then for a total of 15 years, right? So this length of time is 15 years, which makes this 65 years from today. And also this length here is going to be 6 years. And of course, the first chunk of time is 44 years. All right. So for the first chunk, right, from today until 44 years from today, he's going to be putting away payments at the beginning of every month, right? So we've got 1 month, 2 months, and then we need to find, okay, well, 44 years times 12 has 528 months. The second to last one is 527. we don't know what these payments are. That's what we're trying to find. And so, but we do know that they're at the beginning. So we've got a payment here today, a payment, and then the last payment is at the 527 mark. So a payment here. These are going to give us some future value. And because the payments are at the beginning, a future value due. Okay. So then let's deal with the next chunk of payments that we have. And so when he officially retires at 50 years, now he's going to be getting payments at the end of every biweekly period. So here's one biweekly, two biweeklies, and for 15 years, right? The length of time here is only 15 years. 15 times 26 is 390 biweeklies. 389 biweeklies. Dot, dot, dot. Things got crowded. At the end of every biweekly period of $200. So $200 here, $200 here. Just making sure you're putting them at the end. These are going to trace back to some present value, just ordinary present value, because the payments are at the end. So what's going to happen is, okay, well, we'll need that present value in order to get these $200 payments. Right? And then we'll need this future value to have grown to that present value. Right? And so from here, this present value from the payments that we're getting is going to turn into some future value, which can be mapped back to some present value, which is going to be equal to the future value due. This is just a 6-year period where we're just going to assume that it's 7% compounded monthly, because it's not until the $200 payments that it switches to 5% compounded quarterly. And so we've got 6 months of monthly compounds. So n is time times the frequency, which is 6 times 12, which is 72 for that little chunk. What I would recommend is that below each of these, right, we've got 3 zones, right, or 3 phases, right? And so I'm going to use the calculator for each of these. We actually have to start over here to find the present value, and then use that present value as the future value for the next phase, and then use that present value that you find as the future value for the next phase. Right? So it's kind of a 3-phase problem. So for each of these, I'm just going to write out n equals interest per year equals the present value, the payment amount, the future value, the payments per year, the compoundings per year, and beginning or end. And then I'm going to do that for each of these phases. N equals interest per year equals present value, PMT, future value, payments per year, compoundings per year, and beginning or end. And the last phase, n equals interest per year You have one kind of similar, right, on the Moodle quiz, I think. The one that's due, is it due tonight? Can't remember. Maybe. Got a knot up here. No one else knows. No, I've had some questions about the Moodle quiz, so that's why I think it might be due today. Is it due today? Good. I'm just guessing here. I know I set the date, but that was a long time ago. So what we're gonna do is we're gonna fill these in from this right-hand side over to the left-hand side. Right. Whereas I think on the Moodle quiz, you just fill them in from this side to that side, and then you have to calculate the payment amount or something. I've had that question a couple of times now. All right. So let's fill in these values. So for this first one, we've got N is 390. And this is the one where we have 5% compounded quarterly. Right? And just to keep these straight, I'm just going to fill in 5% compounded quarterly. And then what I'm going to do is I'm just so I don't get confused, I'm going to put the 7% compounded monthly for the other two, right? Just so I don't use the wrong one. And so I've got 7% here and 7% here compounded monthly. So 12 and 12. Right? Just kind of slotting all this information where it's supposed to go in the calculator. For this first phase, we're trying to find the present value, so I'll put a star there. And then the payment amount, here we're getting $200 each biweekly period. Right? So we're getting 200, which means it's going to be positive 200. The future value at the end of 15 years, the money's all gone, right? So the future value is going to be 0. The payments per year, we had biweekly payments, so 26, and they are at the end of the payment period. Huh? So what we're going to do is I'm just going to fill in these values on my calculator and find that present value. So I've got 390 for N, 5 for the interest per year, 200 positive for my payments, 0 for my future value, 26 enter payments per year, 4 enter compoundings per year, and make sure I'm in the end mode, and then compute present value. We'll do it green one here. Get -5 for 933.26 678. So from here, I'll say, okay, the present value is 54,933.27. Do you get a different value? Same? Not the same? Should be the same. Maybe. Same as me? Maybe we'll look at it later. So far, I'm pretty confident. So far. But you never know. I didn't have time to go through it on my own, so here we are. So now, this present value, right, the 54,000 is going to be our future value, right, for the next phase. So this one is going to go here, and be used as the future value. So now we've got, I'll put in the number first and then we'll decide if it's positive or negative. 54,933.27. Doesn't really matter for these straight compound interest ones, right? It doesn't actually matter which one's positive and which one's negative. But if we're thinking about it as, okay, so here we were making payments, so that's money leaving our hands, right? That's going to be negative. Making the future value positive, right? Because then I'm going to take it out. But then in theory, what's happening is I'm depositing it again, making my present value positive, or sorry, negative. And then there's a little transition where I take it out and then I put it back in, right? So I'll say it's negative, but for this section, it actually doesn't matter. Okay. Or for this phase, I should say. So now we can fill in the rest of the values here. We found n already is 72. The present value is the one we're trying to find. Our payments are 0, right? There's no payments going in or coming out. Going in or coming out. Going in or going out. The payments per year, if we don't have any payments, do you remember the trick that we used? We just force it to be the same as the compoundings per year. Right? We just say, okay, well, there's no payment, so it's just the same as the compoundings per year. And then for these regular compound interest problems, I actually don't think it makes a difference if you're in the beginning or the end mode, but let's just stay in end mode. You're welcome to check it, but yeah, I don't think so. So now we can calculate the present value of these guys. So 72 is our N, 7 is our I, 0 for our payment, 54,933.27 negative is our future value. And our payments per year are 12, enter. Compoundings are also 12, and we're in the end mode, and then compute present value. I get, change the color here, 36,137.80086. So here the present value is 36,137.80. Which is going to be our future value of the payments that we're making while we're working on Sesame Street. So here we've got 36,137.80. If we're making payments, those are going to be negative, right? And then the future value is going to be positive, right? So here it is important that we've got the right sign for the future value, because if we're making payments, and then we're pretending to make a huge payment of 36,000 at the end, right? That's going to make a difference. So now we're getting this money at the end. We can fill in the rest of the values. So we've got 528 months of payments. The present value, we're starting with nothing, right? So 0. And our payments are what we're trying to solve for. our payments per year was monthly. And the only hiccup is that we're now at the beginning, right? So we have to change to beginning mode. So now 528 for N, 7 for the interest, 0 for the present value, 36,137.80 for the future value. Just make sure payments per year 12, compoundings per year 12, good. And change the mode. Remember, that's the second, and then the payment button has the BGN over top. And then second enter to change it to begin mode. And then you can exit out of there. And now we can compute the payment amount. And we get a payment of, you see the yellow, yeah, or it's orange, I guess, negative 10.19137909. So payments must be $10.19. So monthly payments of $10.19 for 44 years. Let it sit there for 6 years. After that, you'll be able to take out $200 every bi-weekly period for 15 years. Woohoo! Pretty good. Yeah. That one is really tricky, especially if you're trying to do it by hand, right? So I encourage you to get really familiar with using the calculator. It's going to save you a little bit of grief. Right? Any questions about that one? All right. We're just zooming through these. I'm going to break this up. So this is the one that we covered last day. And if you weren't here last day, there's some handouts for practice. So you can come grab those after class. Where we're just doing mortgages. So you purchase a $570,000 home in Lake Country. You're going to make a 15% down payment and repay the remainder of the mortgage at a rate of 4.3% compounded semi-annually. So we've got a rate of 4.3% compounded semi-annually. Calculate your beginning of the month payment if your amortization period is 25 years. For this, to calculate your payment amount, just use your calculator. So what I'm going to do is I'm going to say, okay, well, the mortgage, right, the amount of the loan is $570,000 minus the down payment. Which is 570,000 minus 570,000 times 0.15, which is what? 570,000 times 0.15, 85,500. Oops. Stop me if you didn't get the same thing, because I'm just winging it here, so. Oh. And then 570,000 minus 85,500. So our loan amount is 484,500. That's our present value of our loan. And how we're going to think about it is that we got these payments, right? We got this 484,500, and then we decided to just buy a house, right? But as far as like how the money is going, it's coming to us, right? And then we're making payments each month. So now we can calculate the payment amount, and we can say, okay, well, and we've got the interest per year, we've got the present value, the payment amount which we're trying to solve for, the future value, the payments per year, the compoundings per year, and the beginning or end. I'll squeeze that in there. Lots of room in the beginning. Not so much at the end. So one thing, right, that I don't know if there was any practice with, but here's the practice test, is that these are at the beginning. So the payments are at the beginning, so you have to be in the beginning mode. All right, let's just fill in what we have here. So our interest per year is 4.3% compounded annually. So, sorry, semi-annually. A little line break there. Changes some things. And we're making beginning of the month payments for 25 years. So 25 times 12 means we're making 300 payments. Our present value is 484,500. The payment is what we're trying to solve for. And once we're all paid up, right, at the end of these 25 years, our future value must be 0. So now we can calculate the payment amount. I'm already in the beginning mode from the previous question, so that's very convenient. 300 for N, 4.3 for the interest per year, 484,500 for the present value, 0 for the future value, and then 12 payments per year and 2 compoundings per year. And then I can compute the payments. Just for some room, I get a payment of negative 2,618.670979. So my payment in terms of money is 2,618.67. And you're gonna have to round to 2 decimal places, right? Because it's money. Okay. So now we've calculated our payment amount. So now we can go in and fill in this table. I'll do part B. So now, construct a partial amortization table for the first and second payments, the 115th and 116th payment. But remember, in order to get the 115th payment, we have to know the 114th future value and the final 2 payments. So remember the rule was, okay, the first payment number is 0. And then we want payment number 1, number 2. And then we want the 115th payment. Oh, it's right there. 115th payment, which means we need 114, 115, and then we also want 116. We said we had 300 total payments, right? So 300, but we want the final 2 payments. So to get 299, we need the future value at 298. dot, dot, dot in between. So then we know that the payment amount is $2,618.67 for all of these payments except for the last one. Right? Remember, we have to calculate the last payment amount because that one we have to square up and say, okay, well, I have to pay off all my interest. I have to pay off the entire loan, right? So the last payment amount is going to be a little bit different. But for the rest of the payments, keeping track of, okay, the first row, there's nothing going on except for the initial balance of $484,500. And then the second, or the first payment, $26,1867, $26,1867, $26,1867, just filling it in. And then leaving that last one. To calculate the interest, we have to find I2, right? Because remember, our compoundings per year is 2 and our payments per year are 12, so we have to find I2. And so we have to calculate I2 in order to find interest. I1 is R over F. Is 0.043 over compounded, oh yeah, semi-annually, 2. 0.043 divided by 2. 0.0215. Then I2 is 1 plus I1. Oops, not sure what happened there. F1 over F2 minus 1. 1 plus 0.0215 to the power of 2 over monthly, right? Let me just check. Oh, yeah. Minus 1. Plus 1 to the power of 2 divided by 12 minus 1. 0.00355168, which I'm definitely going to need about 1, 2, 3, 4, 5, 6, 7 times over. No, 6 times, but a lot, right? So I'm going to have to store it wherever you like. I'll do one. But now, right, to calculate the interest at the first payment, we just take the previous balance times I2. And so we've got times 484,500. Well, that's a lot of interest. $1,720. And we have to round to just 2 decimal places, right? So round properly to 2 decimal places. So 0.77. So that we have to pay, right? We always have to pay the interest first, and then whatever's left over of our payment will go towards the principal and paying off the balance. And so 26,1867, that's our payment minus the interest that we had to pay, 1720.77. So 897.90 is paying off the principal. So we can take that off of the previous balance, 484,500 minus 897.90. No, that's not right. 484,500 minus 897.90. Now, oh, 490. 483,602.10. Now we can use that to calculate the interest on the next line, right? So times that by I2. I get 1,117.58. 2618.67 minus 1717.58, 90109, 483,602.10 minus 90109, 482,701. Oops. 01. Oops. Now we have to find the future value at 114, right? The 114th payment. Oh. Sometimes I get stuck. So the future value at payment number 114, now we use n is 114. The interest per year stays the same, 4.3. If I could remember all of them. $484,500 is our present value. We know our payment amount, right? Making sure that it's negative because we're making these payments to pay it off, right? If you accidentally left it as positive, what you're telling the calculator to do is, okay, initially you've borrowed $484,500, and then every month you're going to borrow another 2,618, whatever it is. So you have to make it negative 2,618.67. The future value is still, or sorry, that's the one we want to find. The payments per year and the compoundings per year are still the same. So 12 and 2, and the beginning or end part, well, it's still at the beginning. So 114 is our n, 4.3 is our interest per year, 484, 500. So present value, 2618.67 negative is our payment. And then our payments per year and our compoundings per year in the beginning or end, that hasn't changed. So I'm actually not going to bother going back and putting them in. And so we've got, we can go back and we can compute the future value. If we wanted to just pay everything off at the 114th payment, our future value would be negative $1,280.7274. Is that what you guys got? No? What did you guys get? Good? All right. Solds. So what I'm going to do here is I'm going to say 357, 280.73, rounding properly. Now we can use that to calculate the interest at 115. So 357, 280.73 times I2. Oh, I just stored in one. Oh, how do I unstore something? Come on. I'll just have to calculate I2 again. Maybe he was onto something about storing in 0. I'm going to keep storing in 1, but still. Times 357, 280.73. Now I'm paying $1,268.94 in interest. And so 2618.67 minus 1268.94, 1,349.73, 357,280.73 minus 1,349.73. Hey, nice. And even 355,931.00, I'll say. You could get crafty and store these values as you go and not have to punch them in so much. But for me, that almost gets a little bit too complicated. I would just rather plug in the values. But if you've got a system in mind where you can store these values, then of course that's good. This times recall 1,264,14. One, 3, 5, 4, 5, 3. $354, $576.47. And then same thing here. We need the future value at payment number 298 now. The only thing that's changing, right, is your N. And then you're going to recalculate your future value. Right? So you don't have to re-enter all the values. You just have to change your N, calculate the future value. And so here, and on the test, you don't have to show your work. I'm just showing it so that you've got it. So now we've got N is 298, 4.3, 484, 500, negative 26, 18, 67, 12, 2, beginning. Let me just highlight. So in the future value at 114, the only thing that changed, right, was the N. It was, we added the payment amount. And we changed, well, we had to calculate the future value, right? And then here, the only thing that changes is 298. So now 298 as our N, and then compute the future value. The future value is negative 5,228.582531. So up here, we can say, okay, well, the future value here is 5,228.58. 5,228.58 times I2 is $18.57. 2618.67 minus 1857, 2,610 cents. And 5228.58 minus previous answer. Now I owe $2,628 0.48. The last row is going to be different, right? Because we have to force the balance to be 0. And we also have to pay off the 26, 28, 48 as our principal. Right? And so we have to force that in here, 26, 28, 48. And we also have to pay interest on that, right? So times I2, we have to pay $934 in interest, which means our last payment is going to be the $934 plus 26, 28, 48. 934 plus 26, 28, 48. So our last payment is $2,637.82. Noticing that that one is different from the others. Last part of this question. Is what was the total amount of interest paid on the mortgage? Right, so the total interest is the total paid minus the original balance. The total paid, right, we've got 299 payments of $2,618.67 plus that last payment of $2637.82. So the total paid is 299 times 2,618.67. 2,618.67, yeah. Plus 2637.82 minus 484,500. 299 times 2618.67 plus that single payment, the last payment, 2637.82. So the total paid is $785,620.15 minus 484,500. The total interest paid was $301,120.15. Whew. Any questions? Feeling good? No. It's okay, you've got the weekend to worry about it. So I do have these extra practice sheets for the mortgages. I've posted the solutions, right? So feel free to grab as many as you want because I've got lots of extras. But yeah, if there are no questions, I'll post the short answer solutions. But yeah. All right. See you guys on Monday.